The following video will cover simplifying trig expressions using trig identities. I'll be borrowing problems directly from the H Math. This is for IB Math SL. I'll be covering problems from chapter 11, C and D, pages 266 to page 270. So this is for IB specifically, for IB Math SL, and the trig identities that are going to be required for IB are just the following. You're going to have to use the Pythagorean identity of cosine squared theta plus sine squared theta equals 1. We also have tangent theta equals sine theta over cosine theta. We also have our double angle identities. You can see we do not have tangent theta, the double identity for tangent. We only have the double identities for sine theta and cosine theta. So our double angle identities are for sine 2 theta is 2 times sine of theta times cosine theta. And cosine, the double angle identity for cosine, we have 3 of them. For cosine 2 theta, we have cosine squared theta minus sine squared theta. We also have 1 minus 2 times sine squared theta. We also have 2 times cosine squared theta minus 1. So we'll be using these for the following. I think I'm going to go through 12 different problems. All right, so the first problem that we have, and I lost my pen. So for our first problem, what I'm going to do is I'm going to factor out a -2. So that's going to leave me with -2 times sine of sine squared theta minus cosine squared theta. I'm sorry, if I factor out a -2, I should end up with a positive cosine squared theta. Now, if I look at my identities, cosine squared theta plus sine squared theta, it equals 1. So all of this equals 1. I'm left with -2 times 1, which is just -2. For the next problem, I'm going to identify that sine of x over cosine of x is tangent of x. So I'm going to rewrite sine of x over cosine of x as tangent of x. So I have 3 times tangent of x minus tangent of x. So 3 of these tangents of x minus 1 of these tangents of x will give me 2 of these tangents of x. The next problem, I have 2 times tangent of x over sine of x. I'm going to recognize again that tangent of x is sine of x over cosine of x. That's going to give me 2 times sine of x over cosine of x over sine of x, which is the same thing as sine of x over 1. So we have a fraction divided by a fraction. We'll rewrite this as 2 times sine of x over cosine of x times the reciprocal of 1 over sine of x. We can now eliminate, we have sine of x over sine of x over sine of x, that's just 1. That leaves me with 2 over cosine of x. Number 4, I have tangent squared of beta minus 1. What you should recognize with this particular problem is that we have the difference of squares. In fact, anytime we have a 1, this 1 could be 1 to raise to any exponent. I'm going to raise it to the exponent of 2, which obviously is now a difference of squares. So I can rewrite this then as tangent beta minus 1 times tangent beta plus 1 over tangent beta plus 1. And we should be able to recognize that tangent beta plus 1 over tangent beta plus 1, this is going to be 1, leaving me with tangent beta minus 1. The next problem, I have 3 minus 3 times sine squared theta. I'm going to factor out a 3. That's going to give me 3 times 1 minus sine squared theta over 6 times cosine of theta. And I'm going to borrow this problem. So the identity here, my Pythagorean identity, we have cosine squared theta plus sine squared theta equals 1. If I solve for cosine squared theta, that's going to give me cosine squared theta equals 1 minus sine squared theta. If that's true, then I'm going to substitute this value here right into the parentheses, and that's going to give me 3 times cosine squared theta over 6 times cosine of theta. So I have two of these. Cosine squared theta is cosine theta times cosine theta, so I can eliminate one of those, leaving me with 1/2 times cosine of theta. And there you go. The next problem, I have 1 minus 2 times sine squared 5 theta. I'm guessing that this is going to be more of a double angle identity. I'm going to look at those problems, my double angle identities, and it looks similar to this problem here, so or this equation of cosine 2 theta equals 1 minus 2 times sine squared theta. So that means that I'm going to rewrite this problem then as cosine of 2 times my angle, and my angle is 5 alpha. So that's going to give me cosine of 10 alpha. Next problem, number 7. 2 times sine squared 3p minus 2 times cosine squared 3p. I look at my trig identities. This one looks suspiciously like cosine 2 alpha equals cosine squared theta minus sine squared theta. Well, this is sine minus cosine, so I'm going to rearrange this. I'm going to factor out a negative 2, so that gives me negative 2 times negative sine squared 3p plus cosine squared 3p. I can rearrange these then to be negative 2 times cosine squared 3p minus sine squared 3p. Now I have this arrangement here. So then this becomes negative 2 times cosine of 2 of our angle. Our angle is 3p. I'll substitute that in. That gives me negative 2 cosine of 6p. The next problem. So I have 2 sine 2a times cosine of 2a. That sort of looks like this double angle right here. So that gives me then sine of 2 of our angle, and our angle is 2a. So this becomes sine of 4a. The next one, I have 4 times cosine of phi times, I think that's phi. 4 times cosine phi times sine of phi. That one, well, it looks similar. So I'm going to rewrite this problem as 2 times 2 cosine phi sine phi. And then I'm going to substitute in this sine of 2 theta, or 2 phi. So I get 2 of sine of 2 phi. Three more problems. All right, so number 10. So I have cosine 2 of an angle, cosine squared of our angle minus sine squared of our angle. Looking at our identities, that one looks like this first one here, with our angle being alpha divided by 2. So that means that we have cosine 2 of our angle, and our angle is alpha over 2, which means 2 divided by 2 is 1, giving me cosine alpha as my answer. The next problem, 2 times cosine squared of our angle for theta minus 1. And so that one looks like this last example here, or this last equation of cosine 2 theta equals 2 times cosine squared theta minus 1. So I can rewrite this then as cosine of 2 of our angle, and our angle is 4 theta. So I have cosine of 8 theta. Last one, I have 2 times sine squared of 3d minus 1, which looks like that one looks like, well, we could rewrite it this way, I suppose. So we're going to try to use cosine 2 theta equals 1 minus 2 times sine squared theta. I'm going to factor out a negative 1. That gives me negative 1 times negative 2 times sine squared 3d plus 1. I'm going to rearrange this then to be negative 1 times 1 minus 2 times sine squared 3d. Now these are the same. So that gives me cosine 2 of our angle, and our angle is 3d. 2 times 3 is 6, so I have cosine of 6d. I forgot the negative. Sorry, I forgot this negative here. Negative 1. So there you go. There's the answer. I hope this helped.